Welcome back, everybody. So this is section 2.3. We did section 2.2, right? Yeah, we did section 2.2. Yeah, we got to do section 2.3. I don't think I posted the key yet, or I don't think I showed you guys the key yet. So remind me after we get done with the notes today, I'll do that. I don't want to do it on the video. Don't want to waste that time. So section 2.3, measures of central tendency. Ooh, this is a thick set of notes, people. That is a thick set of notes. Okay, here we go. Good day. Let's go. Measures of central tendency. Now, funny thing is, like my wife, who teaches sixth grade, she teaches measures of central tendency. We're talking about mean, median, mode today, right? Mean, median, mode. That's the measures of central tendency. Like, how do you talk about the center of data? How do you talk about the center of data? That's really what we're looking at today. What defines the center? Okay. A measure of central tendency is a value that represents the typical or central entry of a data set. The first one we're going to talk about is the mean. The most widely used measure of central tendency is the mean. The mean of a data set is the sum of the data entries divided by the total number of entries. It's the average, right? It's the average. To find the mean of the data set, use the following formulas. You know, what's interesting here is they talk about them differently as population versus sample, but they're calculated the exact same way. Now, here's what's important, though. What's important is the notation. What's important is to think about them in two different ways. Meaning, the population mean would be if I took every single person in the population, all of those data entries, and divided them by, added them all up, and then I divided by the total number of entries that I had. That's population, right? That is what's going to be defined as. Anybody know that Greek letter? That like cursive U looking thing? It's mu, pronounced mu. Okay, and that is lowercase mu. That's a Greek letter. Mu is going to be defined as our population mean. Population mean. Whenever you see that symbol, that's telling the reader that it's talking about population, not sample, and it's talking about the mean. So that is considered to be a parameter. Now, how do we find that? Well, we take, now, what is this? What is this weird E-looking thing? What's that? Sigma, right? Sigma, meaning the sum of. That's the math symbol for the sum of. So you say the sum of all of your X values, and you divide it by, now they use capital letter N. That's just the number of things in your population. And again, that is talking about population. Now, the manner in which we calculate mean is the exact same whether we use population or sample. But later on, when we talk about different types of different tests that we do, we're going to need to use different formulas, whether we're talking about populations or whether we're talking about samples. So it's important to understand the notation that we have. So sample, when I talk about sample of a population, okay, I am changing my notation from mu to, this is called X bar. X bar. That's how we say that symbol, X bar. Whenever you put that line over top of X, it's called X bar, or the sample mean. So X bar is equal to the sum of your X's divided by, now they put lowercase n. That lowercase n is just the amount of people in your sample. Okay? That's just the amount of people in your sample. So population is mu, sample is X bar. Population is mu, sample is X bar. Okay. Now, pretty simple to calculate, so let's just, for fun, the weights in pounds for a sample of adults before starting a weight loss study are listed. What is the mean weight of the adults? Let's evaluate it. We got 274 plus 235 plus 223 plus 268 plus 290 plus 285 plus 235. Just to make sure I didn't enter anything wrong. 274, 235, 223, 268, 290, 285, 235. That is the sum. So my sum, oops, that's not a pen. So my sum of my X's is equivalent to 1810. That's the sum. So 18/10, sum of the X's divided by, now what is this? Is this population or a sample? sample. So is this mu or x bar? X bar. So x bar is equivalent to the sum of the x's divided by lowercase n. But again, that's just how many things there are. There we go. So in this case, we got 1810 divided by 1, 2, 3, 4, 5, 6, 7. See what that comes out to be. Divided by 7, and I get 258.57. 258.57. Even if that were representing like something that could be only whole values, be very careful not to round that. Okay, keep that as a decimal value, even though decimals of that thing may not make sense. Like if I was talking about like people or amount of concrete things, discrete things, please keep that as decimal values, because again, we're talking about a piece of data, not necessarily. We're talking about a statistic, not necessarily an actual entry. Okay. For this case, weight, yeah, I could have 0.57 of a pound. But just be careful with that. People always try to round it to the nearest like whole person or whole thing. You don't need to do that when you're talking about statistics, because again, it's not actually talking about a concrete thing. It's just talking about a statistic of that sample. Okay. So X bar in this case is 258.57. That is the average weight of those people, those 7 people before starting this weight loss drug. Okay. The median. So this is the median. The median of a data set is the value that lies in the middle of the data when the data set is ordered. If the data set has an odd number of entries, the median is the middle data entry. If the data set has an even number of entries, the median is the mean of the 2 middle data entries. Okay, so median means middle, right? Median means middle. That's when you line them up and you take the middle number. You may be thinking, well, why would we ever do median? Why not always just do mean? Like, how is median useful? Well, think about this. If I were to find the average salary for 10 people, right? If I said, okay, find the average income, the average salary for 10 people, and I picked, 10 teachers of Lake High School, it would be both the median and the mean would be very, very similar numbers, right? Very similar numbers, right? What if instead of picking a 10th person, I pick 9 teachers and then I pick, LeBron James, right? Okay, what happens to my mean? Goes way up. What happens to my median? It doesn't get affected as much, right? The median does not get affected as much as the mean does when an outlier exists. Okay, we'll talk about that a lot in a minute. We'll talk about outliers, but the median does not get affected, does not get pulled away from the true center as much as the mean would with an outlier. Okay, all right. What is the median weight of those adults? Now, first thing that we would need to do is put them in order, right? Put them in order. What's my smallest here? It looks like 223 is my smallest. And then my next smallest, I've got 2 235s. 235. Those go away. It looks like I've got my next up is 268. And then we got 274, 285, and 290. 1, 2, 3, 4, 5, 6, 7. Again, put them in order. And then we can go from either end and start counting them off. So here we go. We'll go. Median is 268, right? There's our median, 268. If I were to add in another piece of data, say now think about this. Okay, what's the median weight of the adults? What if I had, let me get all my red marks out of here. What if I added in one more person that weighs 700 pounds? Okay, if I were to calculate the mean, look, I still got my calculations in here. Let me go back. Let me take this plus 700. Okay, divided by 8 now. So my mean was 258. That 700 pounder just made my mean go up 60 pounds or 50 pounds, whatever, a lot, just based on that one piece of data. Now, what did it do to my median? So it made my mean increase a lot. What did it do to my median? Well, what do you do if there's 2 in the middle? You find the average between those 2. Okay, so the median is right in there. So I would say 268 plus 274 and divided by 2, which is 271. So the median before was 268. Now it's only 271. So the median didn't change very much, did it? Even though I added in the 700-pounder, the median didn't change that much. The outlier does not affect the median as much as it does the mean. Okay. All right. The mode of the data set is the data entry that occurs the most with the most frequency. If no entry is repeated, the data set has no mode. If 2 entries occur with the greatest frequency, each entry is a mode, and the data set is called bimodal. Mode is just the one that occurs the most, right? The mode I find the least useful, but I don't know. So in this case, the mode is 235. Okay, 235. If I were to change this data set and I said, let me get that back out one more time. Maybe instead of 235, well, actually, if I just did that, we would say that there is no mode, right? Because nothing is repeated. If I kept in that 235 and then also added in another 223, it has 2 modes, 223 and 235. It's bimodal, right? Now think about this. If I add in my big guy, my 700-pounder, the mode was 235. What's my mode now? Still 235, right? So the mode is not affected as much. Well, no, you're right. Yeah, I said that right. The mode is not affected as much or at all when I add in an outlier. Okay? All right. Find the mode of the age of the people in the class. Okay, I've got a 17, a 17, a 17, a 17, 17. Looks like 17, right? Yeah. Okay, that's easy. Why did I have that example in there? Was there a reason for that? Did I have like a note to myself to talk about something? Nope. Okay, I need to take that out because that's stupid easy. All right, an outlier. An outlier is a data entry that is far removed from the other entries in the data set. I think I may have wanted to talk about outliers using stats because there's a 36-year-old in that class, which I would assume is like I put myself in that class when I started this. So I think I wanted to talk about an outlier there. An outlier is the data entry that is far removed from the other entries in the data set. Which measure of central tendency would be the most affected by an outlier? We talked about that already. The mean, right? The mean gets pulled away from the center of the data more by an outlier than either of the other 2 central tendencies. Okay? Mode does not get affected. Mean gets affected a lot. Median does not get affected as much. It does still get pulled away, but not as much as it would have. Okay? So the mean. Okay. What's this here? Table shows sample ages of students in class. Find the mean, median, mode of the ages. Are there any outliers? Which measure of percentage best describes the table order? Do we need to do this? Do we need to do that? Mean, median, mode again? I don't think so. Oh, I think it was just talking about an outlier again. Take a look at that. This is a graphic representation of that last table. Okay? This graphic representation there, where I've got a big chunk here, okay, and then we got this old guy in the class. I have a 65-year-old in the class. Think about where the mean, the median, and the mode occurred. The mode is here. The median of the data set would occur about right here, and the mean is getting pulled away by that outlier, right? Which one is going to be the best measure of central tendency? In this case, because of the outlier, I would probably use the median. Right? I wouldn't want to use the mode because the mode is actually the lowest. It's actually also the smallest amount. Yeah? The median looks like a better representation of my ages in that class. All right. Next thing we're talking about is a weighted mean. Weighted mean. I bet you've talked about mean, median, mode before. Probably haven't talked about weighted mean, even though you do it all the time. You know how we calculate grades? It's a weighted mean. That's a weighted mean. You want to do formative summative? That's a weighted mean. Are we finding average grade? Yeah, we're finding average grade, but the test's way more than the homeworks, right? That's a weighted mean, weighted average. A weighted mean is the mean of a data set whose entries vary weights. A weighted mean is given by, so x bar is equivalent to sum of xw divided by sum of w. Sum of xw divided by sum of w. Now, w is the weight and x is the entry. Right? W is the weight, x is the entry. So sum of xw divided by sum of w. Now, sum of w for grades. Laying down the hole. Weird. Freshmen are weird people. Weird. Sum of the xw divided by sum of the w. Now, when we talk about grades, this is always going to be like out of 100 or out of 1, whether you're talking about a percentage or a, or a decimal. But that sum of w, when we talk about grades, is usually, you're not really going to need to divide it by anything. There are other cases, but, yeah. But we take the sum of the xw divided by the sum of the w's. All right, let's do that. The final grade for a class will be determined by the percentages. The midterm is 30%, the final is 40%, the homework is 15%, and the project is 15%. If you scored an 86, 90, 92, and 75, each respectively out of those, what would be your final score? Okay. And honestly, for you CCP people, this is how our grade gets calculated as well. Each category has its own weight, and within those weights, you're going to get a certain percentage. And from those percentages, you can average out your overall grade. Okay, final grade for the class will be determined by percentages. Midterm. So we got the midterm. Ooh, what jumping around there for? We got the midterm. The X, in this case, for the midterm, is going to be your actual grade. So 86. The weight for the midterm is 30%. And then our next category is the final. And that is 40% of your overall grade. And we scored a 90. The homework looks to be 15%. That goes in our weight. And looks like we got a 92 on our homework grade. And the project looks like we kind of stunk on the project. We scored a 75, but that's only 15% of our grade. Okay, so now what we need to do is find sum of xw's. Okay, so I'm going to add in another column here and find xw. Now, when you're working with grades, for me, I like to use the weights as percentages, decimals instead of percentages. Excuse me. So I'm going to use like 0.3, 0.4, 0.15, 0.15. Okay, so we got 86 times 0.3, which gives me 25.8. So it's giving me 25.8 points toward my overall grade. I have a 90 times 0.4, which is 36 points toward my overall grade. 92 times 0.15. I'm gonna change that. Put those points in there to emphasize it. So 13.8. And then we have 75 times 0.15, which gets me 11.25. Okay, so sum of xw is going to be, let's add that column, 25.8, 36, 13.8, and 11.25, which gets me, I didn't hit the plus button. Entry. Okay, I'm going to go insert here. Plus. Yeah, there we go. 86.85. Now, I've got 86.85. My formula said sum of xw divided by sum of w. The reason I changed those all to decimals because what is my sum of w? What is my sum of w column here? Since I changed them all to decimals, my sum of my w is 1, isn't it? 0.3 plus 0.4 is 0.7 plus 0.15 is 0.85 plus another 0.15 is 1. So when I go to find sum of xw divided by sum of w, I would just divide that by 1. It's a little bit more convenient when you're working with grades to turn one of the columns into percentages, from percentages into decimals, so you don't have to divide it into one. If I had not done that, if I had chosen to use just 30, 40, 15, and 15, I would get 8,685, and then I would divide it by 100, which gets me back to 86.85. So it looks like I'm getting an 86.85% in the class. Questions there for weighted means? Okay. And then we have a mean of a frequency distribution. The mean of the frequency distribution. Why is this important? Well, because think about frequency distributions. Can you tell each individual score in a frequency distribution? No. They're just like categorized, and you can see totals within that group, but you can't really see individual scores. So how can you tell a mean? Well, you can do the mean of a frequency distribution, which is essentially kind of like a weighted mean. Okay, kind of like a weighted mean. Now, is this the exact mean? No, it's just the mean of the frequency distribution. Okay, the exact mean is probably going to be pretty close, but it's not going to be exact based on what we see here. Okay, so the x bar for a frequency distribution is sum of xf divided by n. Sum of xf divided by n. Okay, what is x and what is f? Well, x is going to be the midpoint of the class, which I think I defined on the next piece here, on the next slide here. So x is going to be the midpoint of the class. Basically, like where is that entry occurring? Now, what is the middle of that entry? Middle of that class. Okay, and then you're going to multiply that by the frequency of that class. Did you need something, buddy? I'm just going to talk about our chances. Chances for what? See, you don't even know. You don't even know. We're not taking. You don't even know.
Seriously?
Hold on.
Hold on. I only take this kind of seriously because it's him talking about it.
Okay.
I've not heard of anything.
Wait,
have you already briefed these
You don't
people?
even know. Yeah, this is going to be on our video. This is Mr. Kastenheiser coming in, getting a quick weather update.
Listen, you people are getting awful
You don't
greedy.
even know. Take a look at this.
Is he being for real? Okay, wait. Before I even look, I'm going to ask this because you're pretty good with these.
Mhm.
Do you feel better about this one than you did Friday's?
I do. Stop. Look at this. Where are you going? So you may be thinking, oh, is it temperature? No, it's not temperature.
Here he goes.
Then is it snow? No, it's not snow. It's ice. We're getting ice. We're getting almost 1/10 of an inch of ice, which is a lot. Right at the perfect time.
Who in here likes to play video games?
Woo!
Who in here? Okay, now who in here that likes to play video games? Who's got a pretty nice setup in their bedroom or wherever you play? You got the light up keyboard and all that, right? So you guys consider that you're in the lab cooking. You got the headphones on. Flank left. I got him. Let's run it back. Give me a new skin. Lab's in the lab at home. He's got monitors, just dual Doppler balloons.
Balloon. I got my own weather balloons.
This grinds all weekend. This is all I get on the weekend.
I'm like
updates, weather updates from him.
I'm like 50-60% on tomorrow. See, people that it's like it's going to creep up. Hey, look at this.
All that's in this class?
Yeah.
Hold on. You guys have this.
Stop for a second.
Is this being recorded?
Yes. Look at this. Get out of here. Winter weather advisory.
Okay, listen. This is on record. If Laverick is correct, and I'm still in my favorite hoodie, sweatpants, and I'm grinding some Netflix that I'm watching right now, having a cup of coffee, if I'm doing that tomorrow at this time, I will get this class pizza when we get back.
Hey, you heard it. It's recorded. It's recorded. It's recorded. Okay. All right. Oh, I did say it. Oh, look. Here, I did have it in here. X are the midpoints. Yeah, X is the midpoints. X and F are the midpoints and frequencies of the class, respectively. All right, here we go. So how do you find midpoint? Don't forget to find midpoint of the class. You take lower limit and upper limit divided by 2. That's pretty easy. Some of the XFs, we know what that means. Let's just do an example. Yeah. So this is kind of like a very similar example that I did the other day with scores on the test, right? Do we see individual scores on the test? No, we could not actually calculate true mean here. So what we're going to do is calculate what we see as a frequency mean, okay? A frequency mean, which again is the sum of XF divided by N. Okay, sum of XF divided by N. Now, let's make a couple more. See, I would kind of like space this out a little bit and enter a column right in here, but I'm just going to go with what I see. Because I need an X, right? I need an X. I see frequency. Frequency is F, but I need an X. What is my X going to be? My X is going to be the midpoint of the class. And again, it's defined to be lower limit and upper limit divided by 2. So lower limit and upper limit, 51 and 60. 51 plus 60 divided by 2. So the midpoint of the class is 55 and a half. I only need to calculate that once because then I can see I'm going up by tens. So that's 65 and a half. Can't keep this all straight. Then we got 75 and a half, 85 and a half, 95 and a half. Okay. So what I'm going to do now is calculate XF, which is the midpoint times the frequency. Midpoint times where the class is occurring times basically like the weight of that class. How many people were in that class? The frequency of that class. So weighted, why I'm saying how much it's weighted mean and frequency mean are kind of like the same thing. They're calculated very similarly. All right. So I've got 55.5 times 3, which gets me 166.5. And we've got 5 people in the 65 and a half category, which is 327 and a half. And then we've got 7 people in the 75 and a half, which is 528 and a half. We've got 4 people in the 85 and a half, 342. And we got, oops, that's not right. And we got 4 people in the 95 and a half, 382. Okay, so now sum of XF, 166.5 plus 327.5 plus 528.5 plus 342 plus 382. So sum of XF is 1746 and a half. 1746.5. Okay, so I've got 1746.5, and I need to divide that by N, total number of people in my study, which is basically cumulative frequency, right? So 8 plus 7 is 15, plus 4 is 19. Looks like I've got 23. Right, let me recalculate that. 8, 15, 23. Yep, perfect. So I divide this by 23. Divided by 23, and that gets me 75.9, 0.93. 75.93, that's my X bar. And then go back and make sure that calculation makes sense. Like if you accidentally, messed up your calculation and you got like a 90.93. That doesn't make sense because most of your data is somewhere in between the 60 to 90 range, right? And should be somewhere in between the 71 to 80 range because that's where the most is happening. And I don't see too many outliers happening here. And it looks like a pretty symmetrical curve here, which we'll talk about in a second, where I've got some above, some below, most in the middle, it should land right in the middle between the 70 and 80, 75.93. Okay. Questions about that? Okay, so we got mean, median, and mode, weighted mean, frequency mean, and now we're going to talk about the shapes of distributions. The shapes of distributions. Because what happens if mean, median, and mode all line up? What happens if mean, median, and mode are all perfectly aligned together? Everything is nice and evenly shaped on both sides. We would call that a symmetric distribution. A symmetric distribution. A frequency distribution is symmetric when a vertical line can be drawn through the middle of the graph of the distribution and resulting halves are approximately mirror images. Mean, median, and mode are all right either on or close to the same amount, right? They are very, very, very similar. There are no outliers. Just as much is above the mean as below the mean. It's nice and even, bell-shaped, perfect distribution. That is what's called a symmetric distribution. Mean, median, and mode all lining up together. Nice, neat, organized, pretty distribution. Okay. A frequency distribution is symmetric when a vertical line can be drawn through the middle of the graph when the distribution resulting halves are graph of the distribution and the resulting halves are approximately mirror images. So if we start messing with it a little bit, we can talk about a uniform distribution where it is no longer bell-shaped. A uniform distribution basically says that all entries have the exact same amount. All entries have the exact same amount. Now, what's unique about this? You may be saying, well, mean and median are still lining up, so why was that a defining? But look at the mode. Is the mode there anymore? No, the mode is no longer there because there is no mode because all of them have the same amount. Okay? There is no mode because they are all the exact same amount. Okay? It's no longer bell-shaped. It's more like a, if we're thinking about it in math language, it's like a constant function, right? It's a flat line. Okay? It's not bell-shaped, but a flat line. That's what's called a uniform distribution. Frequency distribution is uniform, or some people call it a rectangular distribution, when all entries or classes in the distribution have equal frequencies. Okay? Technically, a uniform distribution is also symmetric because it's equal halves on either side, but it's not bell-shaped. It's not bell-shaped. Okay? If we start messing with it left and right, we have what's called skew left and skew right. Skew left and skew right. Okay? A frequency distribution is skewed if the tail of the graph elongates more to one side than the other. So we have a bell-shaped distribution, but if I pull some of the data to the left, it's going to elongate off to the right, right? Be careful when talking about skew left versus skew right. When we talk about skew left versus, people tend to say, well, where is the, if the big bump of the data is on the right side, well, that must be skew right. It's actually the opposite, okay? I'm saying, where is the tail? Where is the longer tail? Okay, the longer tail is on the left side. That's a skew left distribution. Look here. The longer tail is on the right side of the distribution, okay? That's what skew left and skew right are. You tend to think the opposite, or sometimes people tend to think the opposite. People look at where the bump is, where the high point of the frequency is, and say, oh, if it's on the right side, then it's skew right. No, it's opposite. Okay. Now, what does this mean? This means that outliers are affecting where the mean, median, and mode are, right? If it's a skewed left distribution, that's saying that there are outliers over here, which means that the mean is getting pulled more to the left. So the mean is further left than the mode and the median, right? The mode is exactly where the highest point is. The median gets pulled a little bit by the outliers, but the mean is getting pulled the most toward the left. That's a skewed left. Skewed right is the opposite. There are more outliers over here, which means that the mean is getting pulled to the right side more than the median and the mode. The mode's still lining up at the highest point. The median is getting pulled a little bit, but the mean is getting pulled the most. right? The mean is getting pulled the most over to the right by those outliers. The median is getting pulled a little less, and the mode is still lining up at the top, the highest point on that graph. So skewed left is the tail to the left. Skewed right is a tail to the right. Skewed left distribution is going to go mean, median, and mode. Mean getting pulled to the left as much as possible. Skew right distribution is going to go mode, median, mean. Okay, mode, median, mean. Cool. All right, let me stop the video there and let me